Welcome guys, I'm DrAvitech, and in this video we're going to be solving this very problem. It says we should find the Fourier series in the nth term for the function f of x equal pi take away x in that very interval 0 less than or equal to x less than or equal to 2 pi, and hence we should deduce this sum of 1 take away 1/3 plus 1 over 5 take away 1 over 7, just like that. Now the first thing I would like to do for myself is to graph that very function. It's easy to do. Sometimes it's not really necessary. For example, this question can actually be solved without graphing. So you can actually graph this without, you can actually solve this without graphing it. But let me just quickly make a sketch. So I know it's from 0 to 2 pi. So am I going to be having something like this? It's at 0, and then let me put 2 pi here. Let me just do it like that. So 0 to 2 pi. Okay. Now, at 0, when x was 0, because this is the x-axis and this is the y-axis. When x is 0, let's put 0 here. Let's put 0 here. So pi minus 0, that will give me what? That will give me pi. So it means my f of x was equal to pi, which means y was equal to pi. So that means there's a point right here. There's a point right here. Next, let me put the 2 pi in. So let me put the 2 pi. Pi minus 2 pi, that will give me minus pi. So it means when it was 2 pi, I was having it at minus pi. So there's something like this. So it means these two will be connected together. But if they'll be connected together, what would be the x-intercept? What would be the x? What would be the x-intercept? Where would it cross at x? Remember that to get x-intercept, you need to make y equal to 0. Your f of s is the same thing as y. F of x is the same thing as y. So make this equal to 0. So you make this equal to 0. If minus s comes over to this side, that means you're going to be having x equal to pi. So our x-intercept will be at pi. So your line is going to pass through this point. And that's just it. So I've kind of graphed the function, even though it's not looking, even though it's not looking kind of fine. So this is 2 pi. Yep. And then this is minus pi. So this is it. So that's just what we have. So let us kind of take a look at this. Though looking at the function already, I kind of know the characteristics. I'm going to make a video soon. So when I do, you watch it so you understand what I mean by looking at the graph and being able to tell what will be encoded or embedded in that very function. So what I want to do is let me find the Fourier coefficients, because the function is neither even nor odd. Remember, for you to know when a function is even or odd, the first thing is your interval must be symmetric. I think that's a misconception most times. Yeah, people get confused anytime they kind of something like this. The first thing you should decide is this interval symmetric? A function can be even or odd regardless. But before you talk about its application to Fourier series coefficients, when it comes to Fourier series, you must make sure that that interval is symmetric. So since our interval is not symmetric, I don't want to bother myself about that. However, this is actually an odd function. Looking at this graph, it's actually an odd function. Looking at it, it's actually an odd function. Because if this line here of y-axis was actually at pi, if I had it here, then it would be symmetric about the origin. But we're going to see more examples on this. So let me find a0. Let's find a0. So remember I said something. I said the reason I am not discussing if it's even or odd is because the interval is not symmetric. That's why. Good. That's why. Otherwise, if it were to be symmetric, then I know that I'm not going to be finding a0. I'm not going to be finding b0 or whatever. But we're not doing that here. So a0 is 1 over pi integral from 0 to 2 pi of f of x dx. But here's the thing. We know that this part here, this part is area. This part is the area of this very curve. This part is the area. And I can tell you that the area is actually 0. Yeah, the area is actually 0. So let me explain why it's 0. Though I'm still going to solve it. Then let's see why it's 0. If you look at this, the area below this very x-axis, so the negative y portion gives us a negative area. Then above gives us a positive area. So let's just discuss about the area of this guy. If you notice, these two should exactly be the same. Why should they exactly be the same? The height here, this height is pi. The height is pi because it's 0 to minus pi, so the height is pi. What is the height of this one? The height of this is also pi. Next, what is the base of this triangle? From pi to 2 pi or from 2 pi to pi is just pi, because you need to add another pi to this pi to get 2 pi. So the distance between this is pi. Then also, what is the distance from here to here? This is also pi. So it means the area of this triangle here is exactly the same with this very triangle. So these two would have the same areas. And this area will be negative, this area will be positive. So whatever number this one gives to you, you subtract it. So at the end of the day, you'll be getting what? 0. But let's solve for the area. Let's see if we'll have 0. So this is 1 over pi. Then we're going to be saying integral from 0 to 2 pi. The function is pi minus x dx. So this will be 1 over pi. Let me integrate. So if you integrate pi, you get pi x. Integrate x, this x here, you get minus s squared over 2. Because remember, the when you're dealing with your limits, you put 1. You put 1 plus 1 over 1 plus 1. And then your limit is 0 to 2 pi. Okay, so this is 1 over pi. Then open up a bracket. The first scenario here is anywhere you see x, you put your 2 pi. Anywhere you see x, you put 2 pi. So we're going to be having the first bracket here. This is pi times, this is x, so I'll call this 2 pi, minus, this is x again, right? So this x will be 2 pi. So that's 2 pi all squared all over 2. So this is the first bracket, minus. For the second bracket, anywhere I see x, I'm going to put 0. So this is pi bracket 0 minus 0 squared over 2. Okay. So this will be 1 over pi. Then I have pi times 2 pi will give 2 pi squared. And then minus 2 pi squared will give me 4 pi squared. Because 2 squared is 4. Then pi squared remains pi squared. And then don't forget that there's an over 2 here. And then minus. For this part, let's look at this carefully. Pi times 0, that's 0. Minus 0 squared. So everything here will just be 0. Everything here will just be 0. Now this will be 1 over pi. And then we have 2 pi squared minus. Now what would this give to me? This right here will be giving me 2 pi squared also. Because 2 here is 1. 2 into this will give me what? 2. So that's 2 pi squared. So this is 1 over pi. 2 pi squared minus 2 pi squared, that's 0. So everything here is just 0. So you can see that this exactly is looking like, it's going to be 0. So that was why sometimes, to skip this process, I can just make a picture of what the graph will look on my head or in my head. And I know that A naught will be 0. Sometimes it helps me out. Why sometimes? It even helps me to even know what the actual area would be. But I only do this if it is linear. Once it's a parabola, I don't do that. I'll just carefully do my integration. So let's proceed. So the next one we want to find is a sub n. So a sub n is 1 over pi, integral from 0 to 2 pi of f of x, cosine of nx dx. So that's a sub n. So this will become 1 over pi, integral from 0 to 2 pi. The function is pi minus x from then cosine of nx dx. So this is 1 over pi. And this is the part where I use my integration by parts. But remember, there's a shorter approach to this. Let me write my pi minus x. So write pi minus x. Now differentiate pi minus x. What would we have? You'll be having minus 1. Why did we have minus 1? Remember that pi is a constant. So if you should differentiate this pi, you will get 0. Then this is minus x. Or you could say minus 1x. So normally, if you differentiate x, you will get 1. But because this is minus x, you will then get what? Minus 1. Now, let's go to the cosine. For this cosine, we're going to be integrating this. So integrate cos nx. We're going to have sine nx all over n. because you must divide by the derivative of the angle nx. So when you differentiate nx, you're going to have n. So you divide by that very n. Now this whole thing here, this sine nx over n, this sine nx over n, integrate it again for this other side. So when you integrate this again, sine here will give us minus cosine when you integrate. Now for us to integrate a trigonometric function, we must always divide by the derivative of the angle. Now the angle here is nx. So if you differentiate this nx, you will get n. So that n would multiply this very n here to give me over n squared. Now remember, you can use the normal integration by parts that you know. It's still the same thing. This is just a faster approach. Now the sign for this, the first one will take a plus, second one will take a minus. Just put the times there. And then your limit is 0 to 2 pi. All right. So let's see where this will lead us to. So this is 1 over pi. Then we have our pi minus x sine nx divided by n. I advise you watch the videos from the beginning of the playlist. It's very important. Now, if you multiply all the minuses here, minus times minus is plus, plus times minus is minus. And this is cosine of nx over n squared from 0 to 2 pi. Okay. Now, here's another thing. Here's another thing. Now, if you want to do this, if you want to solve something like this, what we're going to do next is we're going to be putting our values here. So anywhere we see x, we're going to put 2 pi. Anywhere we see x, we're going to put 0. But remember that sine 0 is 0. Sine n pi is 0. Sine 2n pi is also 0. So this is sine here. So if you should put your 2 pi into this, you will be having sine 2n pi, which is 0. If you should put 0 here, sine 0. So this guy is gone. This guy is gone. It is gone. So it's no longer remaining. So this is what's left. So let's bring out this minus here so that it wouldn't confuse us. Let's bring out this minus. So if we bring out the minus, we also bring out our n squared. The answer of this is also 0, but let's just see. So this is minus. It's going to come outside. So the minus is out. Minus 1. Then this n squared will come and meet pi. So that's pi n squared. Then what's left is only the cos nx, right? That's the only thing left, cos nx. Now this cos nx, put in 2 pi here. So this will be cos 2n pi when you put your 2 pi, because n times 2 pi will give 2n pi. Minus put in 0, that will be cos 0. All right. Now this will become minus 1 over pi n squared. Now, cos 2n pi is a special value, and it's 1. Cos 2n pi is 1. Minus cos 0 also is 1. So 1 minus 1 is 0. So 0 times this will just give me 0. As you can see, it's not looking as if I should have just said it's 0 right from the beginning. But remember, when we finally treat even and odd functions, you will then understand why this is happening. So let's look for the next trigonometric, the next coefficient. So the next coefficient is b sub n. So b sub n is 1 over pi integral from 0 to 2 pi of f of s cos nx. Oh, that's sine, because we're doing b sub n. So sine nx dx. Now this is 1 over pi integral from 0 to 2 pi. Our f of x is pi minus x. Sine nx dx. So this is 1 over pi. Now, using integration by parts, the shorter way is to write the pi minus x first. So pi minus x, then differentiate this pi minus x until you get 0. So the pi minus x, now when you differentiate it, we're going to have minus 1, just like we had the previous time. But if you differentiate the minus 1, you then get 0. But you wouldn't want to write that. You wouldn't want to write 0. So no need for us to write the 0. Just end at minus 1. And this is sine nx. We're going to be integrating sine nx. So integrate sine nx, we're going to get minus cos nx. That's what we're going to be getting. Minus cos nx divided by, now differentiate the n. So what would you get? You're going to get n. So you divide by that very n. Now everything here that we just got, minus cos nx all over n, integrate it again. Now when you integrate the cosine, you're going to get sine. But remember that there's a minus. So you say times, write the minus first. Integrate cos, you will get sine nx. Then divided by, remember that there has been an n here before. So if we should differentiate this nx, if we differentiate the nx, we will get n. So that n will come and make this very n to make it n squared. Now the first guy always takes a plus, second one will take a minus, and then you put your limit 0 to 2 pi. All right, now let's simplify our bracket. Let's simplify our bracket. So this is 1 over pi. The minus, I can just bring it here. So this is minus pi minus x of cosine of nx over n. Now minus 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 will give me minus, because minus times minus is plus, plus times minus, that's minus. Sine nx over n squared from 0 to 2 pi. Now remember that because of the limits, because of these limits, if we should put sine 2n pi, we should put 2 pi here, you will get 0. If we should put 0, you will still get 0. So this guy will just be 0 no matter the limits. No matter the limits. Now let's put in our 2 pi. All right, now there's a way to do this. There's a way to do this. So this is 1 over pi. Let me do this one way and another way. Now pi times this minus, you can use the minus to open up the bracket. You can use this minus to open up the bracket. So when minus goes in, minus times minus s will give me x, and then minus pi. Now because of this minus, listen, if you use a minus to open up a bracket, you are like going to interchange them. So the pi will not be the one to have the minus, then the x will not be positive. Then this is cosine of nx all over n from 0 to 2 pi. Now the only thing that's a constant here is this n. Is this n that is a constant, so I can only bring out the n. So this is 1 over n pi. Then let me put in our limits. Let's put in our limits. So x is 2 pi. So this will be 2 pi minus pi cosine of 2n pi minus, anyway I see x now, I'm going to put 0. So this will be 0, that will be 0, minus pi, then cos 0. That's all we have. Okay, let us see. So this will then become 1 over n pi, 2 pi minus pi, that's pi. So this is pi, cos nx, cos 2n pi here will give me 1, right? And 1 times pi is pi, so just leave this pi like this. Now over here, this cos 2n pi is 1. So 1 times this guy here will give me pi. So cos 2n pi is 1, this will give me pi. So pi times 1 is pi. Now here, cos 0 is still 1. So this here, 0 minus pi is minus pi. So minus pi times this minus will give me plus. To give me plus. So this will become 1 over n pi times pi plus pi, that's 2 pi. So this pi will cancel out this pi. We're left with 2 over n. So that right there will be the value of b sub n. So that's what we have. Now let's go on to the next one. The next part is to get the Fourier series of everything. So before I wipe the board, let me write out every single thing. So this one is 0. This one is 0. So only this guy is existing. So b sub n is 2 over n. So let me wipe the board. So now let's find the Fourier series expansion. So we're going to say f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sine nx. Now this is gone because it's 0. This is also gone because it's 0. So f of s is equal to only this one. So that's the sum from n equal to 1 to infinity. Now b sub n, we had an answer for b sub n, and that was 2 over n. This is 2 over n sine nx. Now, if equation says in terms of n, this is how you will leave your answer. Let me make a simplified version. Sorry. Let me make a simplified version of the answer. So bring out 2. Bring 2 here. Bring 2 to this very location. So that will be 2 because 2 is a constant. So bring out 2. So this is 2. Then the sum from n equal to 1 to infinity. If 2 should leave here, 1 will be remaining at the numerator. So that's 1 over n sine nx. So that's what we have. So this right here, if they say in terms of n, in the nth term, leave it. So this will be the answer. That will be the answer. Now the second part that says deduce the sum of that. Okay. Let's deduce the sum. Before we do that, we have to expand this. We have to expand the Fourier series. So this is f of x equal to, then what will be this sum? Let's open up a bracket. Now when n is equal to 1, this will just be sine x. Plus, when n is equal to 2, this will be 1 over 2 sine 2x. What I'm basically doing is, anywhere you see n, you put the number. So the first thing I did was to put 1. So 1 over 1, that's 1, which you shouldn't write. Then sine 1x is the same thing as sine x, so it's not really necessary. Then the next part, I'm going to be putting 3. So this will be 1 over 3 sine 3x. Next one is 1 over 4 sine 4x. Next one is 1 over 5 sine 5x. Just like that. I can't really get to infinity, so I'm going to end there. Now this is what we have, the expanded form of the Fourier series. But the problem will now be, how would we deduce this? Now sometimes this is what I do. I come back to my function. What I'm going to do is, I am noticing something with that. I am noticing that this 1 here, we kind of had 1 before. Yeah, so there was a 1 here. So this one would exist. This one is not here. There's no 1 over 2. So this guy is 0. So this guy does not exist. This one does not exist also. Next I noticed was the sign here was negative. This was minus 1 over 3. I already understand the function, how it works. Here's how I understand the function. This is 2. The only way for me to get this to eliminate or to go away, the only way for me to eliminate this one is to make it 0. Now what value do you think s should be? So that every single time it's even, it becomes 0. Think properly. Anytime this is sine 2x, so because there are no even guys here, this is 1 minus 1 over 3 plus 1 over 5. So it's like we're dealing with the odd numbers. So no even number. The only way for this x to disappear, that is this even guy, to go away, is to make my s become equal to pi. Because when s is equal to pi, hold on, did I say pi? Let me see. Oh, pi will not work, sorry. Pi is not going to work. Sorry about that, pi is not going to work. As you can see, do you know why I said pi is not going to work? If I just say sine pi here, sine pi will give me 0. So, and this guy cannot go away. This guy cannot go away. In fact, if I should even say s should be pi, every single thing here will disappear. Every single thing here will disappear. So s cannot be pi. S has to be something less than pi. S has to be pi over 2. Now, you agree that pi over 2 is actually 90, right? Pi divided by 2. Pi is 180 degrees. So, 180 degrees over 2 is 90. And sine 90 is 1. Beautiful. So, I've gotten the number now. So, this will give me 1. If I should put my pi over 2 here, so let's do this. Let s equal pi over 2. So, what we need to then become f of pi over 2. So f of pi over 2, because anywhere we see x, we're going to be putting pi over 2. Then this is 2 into sine pi over 2 plus 1 over 2 sine 2 into pi over 2 plus 1 over 3 sine 3 pi over 2 plus 1 over 4 sine 4 pi over 2 plus 1 over 5 sine 5 pi over 2. Okay, now these two we cancel out these two. 2 here is 1, 2 into this is 2. Next, let's go to the next line. F of pi over 2. Let's look at our function. The pi over 2 is contained in this limit, so it's not a discontinuity, it's contained in this limit. Now our f of s is pi minus x. So this is pi minus, our x is now what? Pi over 2. Because we said let s become pi over 2. So since we have pi minus x and s is now pi over 2, that means we're going to be having pi minus pi over 2. Equal to into, now what is sine pi over 2? Sine pi over 2 is 1. And then plus, what will be happening here? This will be 0. Because sine pi is 0. And 0 times 1 over 2 is 0. Let's come here. Now pi over 2 is 90, right? Pi over 2 is 90. So if this is 90, 3 times 90 is 270. So what is sine 270? Sine 270 is minus 1. Minus 1 times this will give me minus 1 over 3. And let's come here. This is 2 pi. 2 pi. You know that pi is 180. So 2 times 180 is 360. Sine 360 degrees, that's 0. So this is 0. So plus 0. Now here, this is pi over 2. Pi over 2 is 90. 90 times 5 is 450. Sine 450 is minus 1. Wait, sine 450, that's positive, sorry. So sine 450 is positive. So plus times will give me plus 1 over 5. So you can see that that's how it works. Let's proceed. Pi minus pi over 2 is actually pi over 2. Pi minus pi over 2 is pi over 2. Pi minus pi over 2. Put over 1 here. LCM is 2. 2 divided by 1, that's 2. Times pi is 2 pi. Minus 2 over 2 is 1. 1 times pi is pi. So 2 pi minus pi, that's pi over 2. So let's proceed. So this will give pi over 2 equal to 2 into, now this is 1, right? So we have 1 minus 1 over 3 plus 1 over 5, just like that. So this bracket is holding what they say we should deduce, the sum. But these two shouldn't be here. These two shouldn't be here. So what we have to do is to divide by 2. Now if you divide by 2, there's been a 2 here. So if you're dividing by another 2, that means what's here will now become 4. There's been a 2 here before. So if you divide by another 2 again, so that means we're having 4 at that denominator. So equal to only the bracket 1 minus 1 over 3 plus 1 over 5, and just like that. So the answer to this question will just be pi over 4. So that's just it. So the sum of all these numbers will give us pi over 4. And with this, we're going to end this very video. This will be all concerning this. I'll see you in the next video.